Okay, so now we will attack one of the big pieces of designing airplanes, especially for World War II, but well, almost every airplane which has kind of difficult junction surfaces, like Karman Fairings, for example, which are the links between the fuselage and the wings. And at the beginning and here you have screenshots of the videos that I made like 2 years back, where I tried a lot of methods in order to have some kind of additive methods. So that means that defining the surfaces and then trying to put the surfaces together into shells and upgrading that using draft workbench, upgrading that as solids and everything, but not really, that was not really working. So the only methods that I could find at that time were subtractive methods, where basically you can see here that you are defining a big block which is corresponding to the, I would say, the shape of the Karman going into the fuselage in a way, so the biggest profile if you want. And here you have the profile that will go into the wing, so you're defining the big block. And then after that, what you are doing is that you are kind of defining Gordon curves that are going through this block. And then I was using at that time freehand B-splines, freehand B-splines that I extended. The purpose of those extensions was to go outside of the block in order to be able to slice it. So that's what I was doing. So once you have done the top slice, you can do the bottom slice the same way. So again, pretty manual effort, freehand B-splines and everything. And also a little bit strangely, I never managed to get rid of those kind of artifacts. The fact that the first surface here is kind of eating a little bit downwards, and the same is true for the for the down surface that is going a little bit upper, and that eats a little bit the upper surface. And of course, once you have that, then you do the fusion. Usually you cross your fingers because either the fusion is working or it's not working, and sometimes you think it works, but a little bit later in the process, when you do some extra cuts or everything like that, you find that it's not working. So you have to find a proper way of ordering the different fusions in order to make sure that you can put everything together. And sometimes you can go with fusion to the end of the process, and you have to use compounds. So it's a pretty manual, and to tell you the truth, this was my first, I would say, full model, which was the NKL 280. And I didn't understood everything at that time corresponding to that. But nevertheless, that worked enough in order to have my first models. For the Renard, I tried some other things, like trying to really blend it using the Curve Shapes workshop. But that didn't work out that much because that was not giving me enough control into the different shapes that I wanted. And so at that time, I got another idea in order to refine the things, which is the fact that I was using some projections of not only the Karman, but the inflated Karman onto the fuselage that I discretized, and I was doing a little bit the same kind of things, like projection on the entrance of the wing, and then a little profile just besides that. For which I use also discretization, and I was able to use those discretized points in order to basically control a little bit the freehand B-spline that I was using. So that was a little bit better in a way. You can see here that especially on this Renard, the Karman is pretty important, imposant in a way. And in fact, that means that the section with the freehand B-splines were really long, and I had to control that a little bit better. but in a way that allows me, using the same kind of methods, to get to some shapes that I wanted. And you can see here that the shape, like for example, this is the bottom of the fuselage. So you can see here that the shape of the bottom of the fuselage, okay, together with the Karman is kind of complex here. So that's not something that you can, easily do without a little bit of sophistication in the techniques, I would say. Because those lines were so long and the Karman was so imposant, so important or large in terms of dimensions, I had to find a way to constrain a little bit, I would say, the B splines. And for this, I've used some hand tuned profiles that I was using in order to again snap the different B splines, in order to make sure that there I had sections that I would also control in a way. So pretty pretty heavy manual process in a way, which was not really completely parametric. So if I change, for example, the overall Karman profiles or projection, then I will have to redo a lot of things. So it was not really resistant, I would say. Like for example, when you upgrade to a new version of FreeCAD, all of a sudden, you have a lot of corrupted files, and you need to work out a lot those kind of things. So I had to find some other techniques in order to get there. Okay, and this is those latest techniques that I will explain to you right now. I found ways to use constructive and additive methods, so using starting from the surfaces and not, I would say, the subtractive methods such as shown up to here. And also I defined some macros in order to automate the process. So I will stop this thing. I will try to put links to the videos that are in French that are explaining this process. And then I will show you the latest method. So it all starts with, I would say, the shapes that you want to have on the fuselage, and the shapes that you want to have on the wing itself. As you've seen, I've defined the fuselage by their skins. Okay, right now, so their surface in a way, the same way for the wing. Okay, which are defined by their skins and not the solids anymore. And the reason why is that that's a little bit easier to have to use, I would say, intersections in order to create the surfaces that are interesting for me. So it all starts with the profile of the Karman hitting the fuselage, and this is the thing that I got here for that. So yes, as you can see, there is a little discrepancy here, but that's because in order for me to ease the thing. And then I'm defining what I'm calling a both profile. So if you zoom in, you will see that you will have two profiles here. So you will have two profiles here. So one is effectively the Karman, and the other one is kind of the inflated Karman in a way, junction to the fuselage. So that will allows me to create little lines that I will use in order to direct a little bit, I would say, uh, the curves that I will use in order to build my surfaces. Okay. I'm using a little trick here that I will show you a little bit later, which is building some little T's here in order to make sure that the distance between the two curves are always the one that I want, which is in my case is 0.15 millimeters, which is the thing that I'm using for the width of the stroke lines. Also, the end is always 0.2 millimeters. That's a little bit, I would say, the minimum that I want to be able to handle, especially when I have to carve out some straight lines again close to the end, to uh, the trailing edge, for example, of the wings. So that's the first thing that I have to build. Second thing that I have to build is this, which is the same thing, but on top of the wing inside. Okay, on top of the wing. So that's a little bit this kind of profile here that we will use both for the front wing and the back wing in a way. So once I have that, I can build an extrude, and that means that this extrude is a wall, and that wall, when I do the intersection with the wing, give me exactly the thing that I want, which is a kind of small surface, okay, that I can use in order to direct a little bit the lines that I will use. And the same thing here, if I take that intersection to the fuselage, then I get these kind of things, which is again the surface that I will use in order to direct the thing. So when I was doing that before, I was using a manual process, and I will show you a little bit the manual process, for example. So here, if I take, for example, this line, well, I will take this line here, and I will go to the curve workbench, and I will discretize that. Okay. Usually by default, the discretization is 100, but that's okay. I will not change it. I will explain to you later why. So, okay, I've discretized that. Then I will take that. I will discretize it the same way. Then I will take that line here. I will discretize it. Then I will take that line. I will discretize it. Now, Control Z. What did I do? So I said that I will take that line here, and I will not approximate, discretize it. Okay, so I have an approximation curve here that I need to remove. So I have my 4 discretization. I will remove those, okay. And then what I can do is that I can, for example, create some lines. So I will create a line from here to here. That's a line. And for example, from here to here. That's a line. The same way here, create a line from here to here. That's a line. And from here to here, that's a line. Okay. And then I can select, for example, this line here and this line here. Okay. And use a curve. Don't worry about that. I will come back later on that. And then I will take that, and I will create a curve again. Okay. So I have my 2 plane curves here. Okay. That I will select. In fact, you have to make sure that the parameters is always 0 here. So 0. Parameters is 0 here also. And then you have to take care about the scales. So I mean, in order to start, I will always use a scale of 0.5 because that allows me to have a little bit more control about what I'm doing. Okay. And as you can see, when I've both selected that and when I play with those numbers, they are changing everything. And now the problem is to know if I have a reverse. So in fact, here you can see that I'm good here, but I'm starting from the wrong side here, which is certainly the first one. So that means that that reverse here, I need to say that it's true. Is that okay? Yes, that's okay. And now I have those curves here, And those curves, if you can look at them from the top, they are a little bit the shape that I could use in order to, I would say, direct all my uh, all my surfaces in a way. So either to build Gordon surfaces or to build like regular surfaces. If I'm not pleased with what I'm doing here, I can, for example, force a little bit more, like 0.7, for example, and that means that I will go a little bit further here in the same direction than this one. And that's the same thing that can be true for that. So I can have, for example, a 0.7 here, and that allows me to change a little bit the shape of my curves. And if I want to be much closer to the, for example, to the fuselage, that means that here, for example, I can use a 1, and that means that now I'm a little bit closer to the fuselage. Now, of course, that's a little bit on the downside. So, okay, so that's the way of let's say creating this kind of curves. And then, of course, after that, either as I said, you use a Gordon curve, or use the workshop surface in order to build your own surface. But as you can see, that's a pretty manual process, so I changed that a little bit, and I will explain to you what I've done. So here I will delete all that, and now I'm back at this stage. So I've defined a macro. As you can see, I have several macros here. One in order to duplicate the cuts, I would say. One in order to duplicate a sketch and assign the named constraints to point to the original sketch. So that's, for example, something that I've used when I've gone from the Karman EYZ inner profile to the both profile. So that means that here all the constraints, they are referring to the Karman YZ profile, which means that I have only one source of truth, okay, here. Okay, so that's a little detail. And of course, there is also a duplicate sketch with all the expressions. And there is this one, which is the create blend curve, which is the one that we are going to use here. So in order to activate that, you need to select in the proper order from the external to the internal the 4 curves of interest, and then you click on this macro. Now you ask for a number of points. Usually it's a multiple of 10 plus 1. The plus 1 allows to have both the first point and the last point, and then to have, let's say, 10 segments or something that are compatible with 10 segments within the discretizations that I will use. And of course, that's linked with the number of lines that I will create. So here I will take the default, which is 51. Do not go below 11, okay? But then after that, if you have a bigger plane or everything like that, you can go to 101 or 201 and whatever. So I will take that. It's working, and as you can see, it has generated all my lines here, which are grouped into a group. So in fact, in this group, what do we have? So here I will stop showing this. So in this group, we have the discretizations. Then we have created the lines out of that you can see here. And after that, we have created the blend curves. And all those blend curves, they are, I would say, defined into this directory here. One of the interests of having this directory as such is that you can select them all like that, and you can change the scales, okay? of let's say the associated to the wing or to the fuselage, for example. So once you have that, what do you do? Well, that's pretty easy. You take all of them. So I didn't automate this part because I think that there is a kind of in the surface workbench. There is, I think it's pretty. It's rewarding to see the surface building as soon as you add edges. So here, of course, I will start from the first one. Then we will build gradually this. So it's a kind of easy process in a way. You can see that here, I think it's a little bit far away, but nevertheless, we can manage to do things. And that means that here, when I click on OK, we have our, so this is the back Karman. So this is the back Karman top surface. Of course, I don't need that anymore. Okay, so as you can see, I mean, that allows to have something which is pretty smooth, which is regular. Now, as I said, if you do not like, I would say, the shape, or if you want to change some parameters, it's pretty easy to do so. Now I will bring back my two reference stuff. Okay, and I will do the same for the lower part. So I will select 1, 2, 3, 4, and then in the part workbench or wherever you put them, you activate the macro with 51 here again. So just so for this, I had to learn the macros, and of course it's a little bit documented, but not completely. So you have to use the forum, and really, I mean, one guy in the forum, Christophe Grelier, really, who is, I think, one of the main contributors to the Curves workbench, really helped me a lot in order to, let's say, find my way in all this new territory for me. So basically, we have the second one here, okay? And so the same thing here, I can go into the surface and go to this add edge. Yeah, a little caveat. We will build the solids out of those surfaces, and what's really important is that the edges of those surfaces are very well defined or are exactly the same. So in fact here, as you can see, I have my first edge here, but in fact this first edge is also in the in the top surface. Okay, so in fact what I'm doing right now is that I will not take the first one here, and I will take the one from the surface. At the end, there is this distance of 0.2 millimeters, so it's not really the same, so that's okay. But here at the start, I want them to be really the same. The same. So this is why I will use the edge of the surface as the first line instead of any other one. So now I can go back, add edge. Here it's the top surface edge 2, and then I'm going to my regular pattern. Because of this, you see that I'm stretching a little bit too much, I would say, the, let's say, computations of the surface algorithms. So this is why I could choose perhaps to have a more, sorry, to have more point, sometimes you really to be a little bit careful here about the way that I'm manipulating my stuff. Okay, sorry. And then I'm finishing that with those. And the very last one. Okay. So, yes. So this is my back Karman bottom surface. Back Karman bottom surface. And now I can play with things in order to, let's say, in order to build my solids. Okay. So how to do that? Usually I'm taking the simplest way when I have the choice. So the simplest way is, for example, here, to go to the part workbench and to do a stretch, okay, ruled surface between, for example, this and this, and I create a ruled surface. I could do the same here between, I would say, this and this. But I will need at one point another surface to do so. So this is why I will show you how to create a little bit more, I would say, complex surface. So I will go to this one, the surface workbench again, and I will create filling my surface. Here, add edge is automatically, I would say, scheduled, so that's okay. So what I will do is that I will select this and then this. Now, of course, you are a little bit worried about what's happening here, but don't worry, we're gonna correct that. But for that, I need two things. So first of all, I keep it like that, but then I bring back my back Karman here. And in fact, here I have one edge which is very interesting, which is the one that I want. So I can bring back my rule surface, my surface here, sorry, and add edge, this one. And magically, that's pretty good. Click OK again. Now I do not want to add that, but I want to have the fuselage rear skin, okay? On that fuselage rear skin, I will use it again in order to have my support surface here, like this one. And I click on OK. What it means? It means that now I have a surface here which is really adjusted to, I would say, the fuselage. Do I need that? No, not exactly, and I will show you why, but I will show you the little problems that we have sometimes with making solids out of surface. And now, of course, I have a last surface to be doing, which is this last one here. And here I will use here the surface with the add edge here. So where are they? They are here, and then here, and then here, and then of course here. Okay, I click on OK. And now I have all my surfaces that should be allowing me to create my solid. But as you can see here, this one is not very good. So I will see if a simpler one could be used. So for this, I click on Supr. I'm just using the regular filling here. Add edge with a stretch one. So this one, this one, this one, and this one. And as you can see, it's a little bit, because it's a stretched surface, it's a little bit more, I would say, regular, and it's a little bit more suitable to what I want to do. But as you've seen, there is some little trouble with the back here. I mean, it's very likely that, for example, the surface of the fuselage on the external surface here, they are kind of overlapping. But I will show you a little bit what does that mean. So now I have my ruled surface here, which is the external. So that's the back Karman external surface. Okay, whoops, external. Okay. Now I have here back Karman fuselage surface. Okay, and then we have the back Karman trailing surface. Okay, I will not use so I prefer here to call here the wing surface. Okay. Okay. Whoops. That's okay. Yes. You will see that we will create a lot of surfaces, so it's pretty important to have them, well named. So now I will select all of them. Okay, 5 surfaces. I go to the Curve Workbench and I create a solid out of that. And usually it's pretty magic, but it's a good solid. Okay. Now, is it a good solid really? So that's something that we are going to see, because as I told you, there is a chance that some surfaces kind of touch, very, very softly, but they touch. One way for me to check all that is that, this is why I think I've told you what I'm doing here. I have something which is what I'm calling my test sections, okay? And in fact, my test sections allows me to test if the solids that I've created or the fusion that I'm working on, they are good. How do you do that? Well, you take that solid here, you take the test section, and in the part workbench, you create an intersection. And as you can see here, right away, that's not working. And that's not working because of the conflict of surfaces that I told you, okay? So normally, my solid, okay, I should have, all the good profiles and everything like that, and then that. So that means that if that's solid for one way or another, I'm trying to fuse it or to do a union with a fuselage, well, it's very likely that it will not work, or it will say that it's working, but in fact, it's not working at all. So, like, if I have my, do I have my, I will have to check if I have my fuselage solid, and if I have my fuselage solid somewhere, I will try to do a fusion. So I've renamed my solid and I found my fuselage. My fuselage real solid is here. So like for example this one, okay? And in fact, just for the fun of it, because sometimes the gods of the fusion are with you, you can take this one, this one and try for a fusion, a union. Okay. And guess what? This time it worked. So did it actually work? So that means that if, for example, I do that with the test section and I do an intersection, it worked. So, okay. That means that the gods of union are with us with this. So, but frankly, when I see that the original, this is why I've called it back Karman small wrong, when the original is not working in terms of cuts on sections and everything like that, and the rest is working, you are taking your chances. That means that at one point perhaps something will break or not. So this is why I will not use that kind of things here. But I will try to see if I can change a little bit the things. So in order to avoid the precision problems that we have around these surfaces here together with the fuselage, the idea is to extend a little bit this. So since I have this profile here that I've used in order to do the extrude, in order to do the cut or the intersection with the skin, I can eventually use it in order to build a bigger piece. At the end of the day, I will have something that will resemble, I would say, the shape of the parts that I had when I had my subtractive methods. So here what I will do is that I will select this line here. I will select the top of the line in order to go in the material that I have in my fuselage, and I will create a stretch curve here. Okay, now I can do a little bit the same, and using also a kind of stretch curve, the same thing. So in order to do that, I will go to the surface and I will do this using the stretch fill type, and I will take no, here you have, sorry, here you have to select to add edge. Yeah, it's not really consistent. This one, and this one. And now I have this other surface here. Okay, and now I can not see this one because again, as always, I want to make sure that I have the same border, the same edges of the surface that I need. I can go to part and to go from here to here and do a stretch again. Okay, and now of course, as usual, I have my last little part to do. I had the trailing here, so I just have to have this swing now because I will go to my surface and I will go here, add edge here, 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 and here. Okay, and here again I have a given number of let's say surfaces, and I can always take them one by one. Yes, go to the curves workbench and then create a solid out of that. Now I have my second solid here. Okay, this second solid, now always the same thing. I would like to test it if through the test section it's okay or not. Part intersection. As you can see, this one is working in terms of let's say intersection. So that means that seems to be a good solid this time. So I think it's good. And now same thing with the fuselage rear solid. So not this common, but this solid here, together with the fuselage rear solid here. I will try to do the same thing and to create a fusion out of that. And as you can see, you think it has worked, but of course it does not work. So that means that the fusion is not good here. Okay, and that means that if this fusion you want to test it with that, you will see that it's not working. I mean, the Karman has not been taken really into the fusion. And again, that's why is that? That's again the problem of precisions around the, I would say, the two surfaces about the Karman and the fuselage itself. Um, Before I had the surface itself that could be used in order to, let's say, do the junction of the fusion. So the fusion kind of worked at the given precision that they are working here. But here, the gods of precisions are set up in such a way that, in fact, this fusion is not working. So that's always a little bit the tricky part of that is that you never know. First time the object was not good, but the fusion was good. This time the object is good, both objects are good, but the fusion is not good. So can we fix that? That's something that I will try to do. So since we know that it's certainly, at the mix, and you can see here, there are some little overlap here, and in fact, as you can see, I mean, sometimes it's the fuselage, sometimes it's the Karman itself that has, I would say, you can see here also that this little thing here. So sometimes it's, again, a problem of very, very small precision about the fact that one solid take precedence onto the other when we do the fusion. And so the problem is to remove this kind of, I would say, temptation or whatever, or precision problems. So what do we do? In fact, we could remove the section that is generating the problems. And remember that we had here a back Karman fuselage, so we had something which is really onto the same surface that we have built. In fact, what I will do is that I will use an extrude, and I will use an extrude of let's say 1 millimeter in that direction and 15 millimeters in this other direction in the custom. Oh, yeah, okay, in the custom direction. That's going to be X, of course. So that means that we have built something, that is going through, I would say, the fuselage. So in fact, I will take this fuselage, I will remove that. So that means that we have something with a hole here. And remember, we've went a little bit further, like the 0.15 millimeters. Okay, so that means that if I take that cut now and add this Karman and I do a fusion, we will go a little bit higher here, and guess what? The fusion has worked. So is it a true fusion or not? Again, same thing. We'll take that fusion here, we'll take our test section, and we'll create an intersection. And we can say that this fusion has worked with both solid as good solids. So in a way, we are pretty good. Another way of seeing it is that we take that fusion, we remove the fuselage and everything like that, so all the cuts that we had prepared, okay, sorry for that. And in fact, that cut, we will do the same thing with the test section, like intersections, and everything seemed to be fine. So that means that we certainly have a good way here in order to have a solid that represents our bike fuselage. So that's a little bit how you can build, I would say, fusion when there are a little bit problems with respect to surfaces that are too close, and that generates precision problems. So I will generate myself the front Karman, and then I will come back to you with the end of this session, I think. Before that, some little comments on the on the macro itself. So as you can see here, if I'm using the one that we have used in order to generate all our surfaces and everything like that, and this is why I'm telling you that this is why it's very important to use the surfaces that I've created in order to create the solids and everything like that, the edge, because as you can see, there is a little difference between the profile that we wanted and the thing that we got at the end, with a little angle here. And in fact, if you looked well, you've seen that when I generate my blend curves, group blend curves, you can see that, okay, you ask for 51, but in fact, there are more at the beginning and more at the end, especially at the beginning because of this aspect here. So 51 is really used for those things here. And so, as you can see, the surface that we have generated is not fully precise enough in the leading edge, okay? And so this is why you can sometimes eventually use a bigger numbers. So I will show you a little bit how to use that macro for a bigger number. And the fact that in fact this macro is generating more at the beginning, a little bit less in the meantime, and so on. So in order to do so, I will remove that and that, and I will again ask more for my basic surfaces, okay, and I will create here this one, select this one, select in the good order this one, and I will ask that, and here I will ask for 101 number of points. I have much more, and I have much more here, okay, and all the idea is that to see if that's enough in order to generate, I would say, a proper curve here. And that's something that you can do, or you can go to 201 and everything like that. As you can see, when you're asking for 101, we only create 39 because in those sections here there is not that much to do. But again, that's a little bit the same thing. I think they are still selected, so I will try to use that the same way, and I will put here 201. And yes, I have my, so if I do not ask for that, but here I have more that are generated, of course, at the end and at the bottom. So it's free for you in a way, but you can be a little bit more sure that there will be a good match between the curve that you want at the beginning and the curve that you get. So that's one first remark about that. The second remark is that you can tune things in batch. So again, if I've kept my 51 here, so this is the curves that I'm using. Okay, I think on top seems to be okay. Okay, but as you can see here, I do not like too much this angle here, but again, this angle can be changed if I increase the number of lines that are at the beginning. So that's one thing. But also sometimes I see that I'm not completely pleased with the shape that there is here. Okay, and in fact you can change that. So I will not do that for the top curves, but I will do that for the bottom curves. Remember that the first one is not used, in fact. Okay, so that's okay. So the good news is that here we are using the scale parameters that are a little bit, I would say, controlling the strength of the link between the little lines that we are using in order to build our blend curves. So in fact, we can change that in bulk. I've selected them all, okay? And in fact, I think that we are going from the external to the internal. So if I want, for example, I would say the wing to have more influence, okay, I can increase that. And for example, I can say that I want here to have 0.7. So it's not point, it's a comma, okay? So careful here because I would say the way that this is input is a little bit different. And so it's not a regular value. I don't know exactly what it means, but anyway. So it's a 0.7 in French, okay? And then if you click on return, all the plane curves are updated, okay? So that means that with one command, I changed all the parameters of the plane curves. I think that's pretty useful, and this is why I wanted in the macro to make sure that I have access, I would say, to real objects that are really free CAD objects. And as you can see, well, that's working not too bad. And that means also that you can change that, as you can see, even after I've created my solids and everything like that. So in a way, it's parametric. The only thing that is not completely parametric is the discretizations. So usually the discretizations where you are changing, for example, the profiles, discretizations needs to be recomputed and recalibrated. Okay, so that means that you just go to the discretization objects and you reselect, I would say, the proper curve that are used as a basis or as the link object of the discretizations, and then everything is going fine. So that means that, again, this technique is somehow semi-parametric because you can change things very easily and you can change things in bulk. Now, of course, if you want not to change things in bulk, but for example, to say, as you've seen, we've seen that we have here at the end a little angle that is generated. So perhaps it would be interesting to have the last ones, like for example these ones, and perhaps these ones, and we would like these ones to have a fuselage which is much closer. So like for example to be one, really a strong strength with a fuselage bound. And you will see that again everything is doing okay. So that means that here I have a much closer, I would say, bound to the fuselage in a way. And that means that if I'm looking, for example, now at my common here, so sorry, not the fusion, but the common, I should see that here there is a less of an angle, okay, but there is still an angle, so we're still not exactly doing what I would love to do, which means to have a kind of perfect, I would say, smooth line and everything like that. The fact is that usually there is a straight line at that level, at that junction, so most of the time this will not be really a problem. So that's the two last things that I wanted to share with you on this. And again, I will try to finish the model and show you the end results. So for those who would like to start from the skins on the external skins in order to create the full solid, in fact, you can do it also. So here, for example, if I take the skin that I've created for the last part of the fuselage, and so this is this one, and if, for example, I cut this as a little hole, so I do a cut. Yes, I want to continue. So I have this section here. Now I can bring back all all the surfaces that I have used in order to create my Karman as a solid, which are those ones. Okay. So I have Maquette, I have those ones, and remember that at one point we have created the solid out of the skin of the rear fuselage. So somehow they should be somewhere, which is the rear front surface, the rear mid surface, and the rear surface. Okay, so I have all that, which are all the external surfaces of my solid, and basically I can take all of them here. Okay, those three ones here, then those four ones, then this cut, and I can go to the curve workbench and create that as a solid. Normally, if everything goes fine, I have a full solid made out of all those surfaces. Okay, and that means that this solid, as usual, we will do our little tests. So we will cut the fuselage cuts. So I will go back to the parts workbench, create a cut. Seems to work. Okay, it's here. And that means that if I take that cut and I compute the intersection with the test sections, seems to work. So that's another way of creating the full body, starting from the overall external skins and putting them together into a single solid. Now, here that does not involve a hole, I would say, in the body solid and in the fuselage solid and everything like that. So I think it's a little bit, I would say, safer to use that if you have found a proper way of doing it. Um, that's it for now. Another possibility to use this, especially to make sure that you have more closer kind of adherence with the curves, is yet again to go into the surface workbench and to use fill, and to say that you will go from here to here to now you have to find it back if you can, which is sometimes a little bit a problem. I think that this one. So it's a little bit frightening at this point. And then you need to close it with this one. Okay, a little bit less frightening. So now we have this here. And in fact, you can use the fact that you can have boundary edges, okay? And so edge constraints, I would say. And then you can add, I would say, these edges as constraints. And here you need only the 51 version because that's usually enough. So it's another way of making sure that you have the proper shape. And here we are. and we can click on OK. Don't ask for this group, and we have here a surface that, as you can see, is following much more closely, I would say, the one that we want. The problem is that it generates some artifacts here, so I will have to make sure that I understand why there is these kind of things here. But that's another way of generating those surface here. And again, in order to cope with the problem of, let's say, the leading edge here. Now, as I said, you are generating other little problems here, but I think that's also another way of doing it. But the very last possibility for all this is to generate simply the lofts, okay? And here, as you can see, I've generated a loft. So of course, I've generated kind of a lot of, let's say, blend curves. In fact, I've generated something like 200. Okay, that's the thing that I've asked for. And in fact, you can create something which is pretty smooth that way, and that follows the curve pretty good also. And so that's something that then after that you can build as a solid, as I've shown before. And in fact, you can even do the join, the fusion, I would say, and then doing the cuts and everything. So everything is fine with this kind of thing. So that's the last possibility, which is a loft. Now, of course, if you're using a loft, you need to generate a lot of curves in order to make sure that you're following as much as possible the lines. So that's the last possibility. And in fact, to tell you the truth, I've generated everything as a fusion, which is this thing here. And in order to test it, I've exported it as an STL. And in fact, at the beginning, so that's at the beginning, I have exported it, as such, whatever. And then, using the techniques that I've shown elsewhere, I've generated a clone with the angle in this view position, the angular deflections to be 1, as usual. And that gives me this thing, which is pretty good. So that means that now I'm almost sure that I can generate everything corresponding to this. So, and you can see here that the junction, okay, is pretty smooth in the Karman. So I think that we've managed to do it in a way, and so I think that's pretty good. So I think that's it for this now. Yeah, see you soon.